Around the end of each year, an email like this lands in my inbox, pretty much asking for who came first academically across each grade, and some other related things as well. Now, how do we work out something like this? Suppose we have a student who achieved these marks in English, Maths, Bio, Legal, and PDH. We could work out an average for her, which in this case is 84, and we could do the same for the next student, who does very similar subjects and has achieved some very similar marks as well. We could work out an average for him, which in this case happens to be 85. And presumably we could rank the grade according to their average scores. But if you look closely, there's a bit of an issue with this approach. See, if we look at the maths results, or more specifically the maths courses, we find that Alice actually took advanced maths and Bob took standard. And so while Bob achieved a higher raw mark, it's actually quite possible that Alice's score of 85 is relatively a bigger achievement than Bob's. Not saying it has to be, but it's definitely possible, and so we need to look at the bigger picture here than just the raw marks themselves. And that would be especially the case when we have people doing all sorts of different subjects, right? We need a way to sort of standardize these marks and have a fairer comparison. So this topic gives us a starting approach for how to deal with this issue. So just to have something more concrete to think about, we're going to ask a question like, how good is a mark of 80? Alright, and the idea is to be able to compare how good a mark like 80 is across different subjects. Just a disclaimer here, the immediate audience of this video is probably Year 12 from 2022, so just for fun, I'll actually be using your real data from Year 11 last year. So let's start by taking, say, Advanced English, with its distribution of marks across the grade looking something like this. And we'll compare that with Extension Maths, with its distribution of marks across the grade looking something like this. Now remember, we're asking how good a score of 80 is, and we can already sense that getting an 80 in Extension Maths would have been a much bigger relative achievement than getting an 80 in English, right? And you're doing quite well either way, but in the maths, you would have beaten almost your entire class. Alright, so our aim is to be able to describe this numerically in a way that is somewhat standard and consistent across all possible subjects. And while this isn't perfect, one way is to fit the data to these sort of bell curves, assuming that real-life data quite often follows a shape like this, with the bulk of the scores somewhere around the average, then with a smaller top end and bottom end. We call this shape a normal distribution, and it's very widely used in this sort of analysis, even though this is a somewhat simplified version we're giving here. Okay, and now if we look at the English curve, the peak is at something like a mark of 70.5 or something, and that peak is always placed at the mean score, at the average. So down in the maths curve, the peak is found at a score of something like 46, which was the average mark for that class. Then how do we make a call on how good a score of 80 would be in each of these subjects? Well, up top for English, the average was 70.5, so we know we're above average. But more specifically, we're this far down the bell curve, which is not too shabby, I guess. But if you look at the maths curve, the average was at 46, and so we're well above average. And again, more specifically, we're this far down the bell curve, which is comparatively a far more extreme score. We're much further down the positive end of the bell curve, which means that last year, the 80 would have been a much bigger achievement in Extension Maths than it would have been for Advanced English. So the big idea is this: we measure how good the mark of 80 is by seeing its position on the bell curve, on the normal distribution built from the performance of the entire class. And it's this position that matters, not the mark of 80 itself. Okay, but how do we measure this position? Alright, this is where we will eventually use numbers to precisely pinpoint the position, but not till the next video, okay? For now, I just want you to be able to feel the importance of the two main ingredients we will use. Okay, firstly, it's important to know the average. because how far above or below average you are matters, and I think this was very clear in the example we just saw on the left there. But that's not the only thing that matters. And to illustrate this, I'm going to pick on another two subjects from Year 11 last year, Standard Maths and Legal Studies. Okay, after fitting the scores across the two classes to normal distributions, we have curves that look like this. Now, importantly, they had very similar averages. In fact, Maths was 73.7 and Legal was 73.6. So our mark of 80 is, well, equally above average for these two subjects, right? Well, no. See, the Maths curve is so flat and wide because the scores happened to be super spread out. The average was about 74, but that came from a very wide range of scores, so comparatively, our 80 doesn't actually mean that much anymore, right? It's just this slight little bit above average. While for Legal, the curve is so tall and narrow because the scores happened to be much less spread out. The average was about 74, and it was also true that most people got close to 74. So because a lot of people got close to 74, suddenly your score of 80 looks like a much more outstanding achievement. And mathematically it is. You can see that the score of 80 is a fair bit further down the positive end of the bell curve, which should correspond to a stronger score. And so we must take into account not just where the average is or how far above or below average we are, but also how spread the scores are. If the scores are super tight around the 74 average, like in Legal down there, then a score of 80 or 90 would be quite outstanding. You'd be quite a bit ahead of most of the others. But if the scores are super spread out, like in Maths up there, then a score of 80 or 90 is still good, but a bit less significant. Okay, it's a less outstanding achievement compared to the rest of the class, because there's probably quite a few scores up there with you. Now that's where I'd like to stop for now. In the next video, our goal will be to measure these positions on the bell curves precisely with numbers, which of course is when these somewhat vague ideas will become concrete and usable. Okay, so that's all for this one. Thanks for watching. See you next time.